Good day, this is Basic Calculus. Topic, Chain Rule. In the introduction, we have observed that the power and the product rule are not always efficient methods to find the derivative of a power of a polynomial. For example, we have f of x equals the quantity of 3x plus 1 raised to the 10th power. F of x equals the quantity of 3x squared plus 4x plus 2 raised to the 5, and f of x equals the fifth root of x squared plus 3. Now, a binomial, trinomial, or polynomial raised to the nth power can be expressed into n factors. And the best way to deal with these kind of functions is to treat them as a composite function and apply the chain rule. Chain rule helps you save time in finding the derivative of these kind of functions. So by definition, the derivative of composite functions, let f and g be two differentiable functions. The derivative of the composite function f composed of g of x is given by f composed of g prime of x is equal to f prime of g of x times g prime of x. Another way to illustrate the chain rule is using the Leibniz differential notation to state if y is a differentiable function of u defined by y equals f of u, and u is a differentiable function of x defined by u equals g of x, then y is a differentiable function of x, and the derivative of y with respect to x is given by the derivative of y with respect to x is equal to the derivative of y with respect to u times the derivative of u with respect to x. Now let's have example 1. Let's go back to f of x equals the quantity of x squared plus 3 raised to 10. Find the derivative using the chain rule. First step will be, let the inner function of your given function be equal to u. Okay, so in this case, f of x equals the quantity of x squared plus 3 raised to 10. Our inner function is the function inside the parentheses. So you have here x squared plus 3. So we have let u be equal to x squared plus 3. Next is we have to rewrite our function f of x equals the quantity of x squared plus 3 raised to 10. So f of x equals the quantity of x squared plus 3 raised to 10. We write this into y is equal to u raised to 10, because here we let u be equal to x squared plus 3. Okay? Next, we can proceed with finding the derivative. So following Leibniz's differential notation, let's have f prime of x is equal to the derivative of y with respect to u times the derivative of u with respect to x. So here we have the derivative y now is equal to u raised to 10. So you have here u raised to 10 with respect to u times the derivative of u. U here now is x squared plus 3. So you have x squared plus 3 with respect to x. Now find your derivative. So you have derivative of u raised to the 10 is equal to 10 u raised to 9 times the derivative of x squared plus 3, that is 2x. Next step, we substitute our value of u that we first defined here. Okay, so we have 10 raised to the power of, no, times the quantity x squared plus 3 raised to 9 times 2x. Multiply, so you have here 20x times the quantity x squared plus 3 raised to 9. And that's already our f prime of x. That's already our derivative. Okay, that's your final answer. Let's have our second example. Solve for the derivative of f of x equals the quantity 3x minus 2 raised to 4. So solutions. First, identify your inner function. So we have here 3x minus 2. Now let that be u. So let u be equal to 3x minus 2. Next, rewrite your given function. So we have here f of x equals the quantity 3x minus 2 raised to 4. Rewrite this into y equals u raised to 4. Now you may start finding the derivative. So we have f prime of x is equal to the derivative of y with respect to u times the derivative of u with respect to x. So we have here the derivative. Our y is u raised to 4. So we have u raised to 4 with respect to u times the derivative of u. We have 3x minus 2 with respect to x. Find the derivative. Derivative of u to the 4 is 4u cubed times derivative of 3x minus 2 is 3. Next, substitute your value of u defined here. We have 3x minus 2. So we will substitute that. So we have 4 times 3x minus 2 cubed times 3. Multiply, we have 12 times the quantity 3x minus 2 cubed. And that is already your derivative. Now let's have example 3. Solve for the derivative of f of x equals the quantity 3x squared plus 4x minus 5 raised to 5. Alright, so step 1, of course, you have to find first or determine the inner function. In this example, we have 3x squared plus 4x minus 5. So let u be equal to 3x squared plus 4x minus 5. Okay, and then rewrite your given function. We have f of x equals the quantity 3x squared plus 4x minus 5 raised to 5. Rewrite that into y equals u raised to 5. Alright, next we can start solving for the derivative. So we have here f prime of x is equal to the derivative of y with respect to u times the derivative of u with respect to x. So we have here the derivative of y. Our y is u raised to 5. So we have here u raised to 5 with respect to u times the derivative of u, our u here is 3x squared plus 4x minus 5. So we have 3x squared plus 4x minus 5 with respect to x. Next, we have, find the derivative of u raised to 5, that is 5u raised to 4 times the derivative of 3x squared plus 4x minus 5. So that would be 6x plus 4. Next, substitute our predefined value of u, which is 3x squared plus 4x minus 5. So we have here 5 times 3x squared plus 4x minus 5 raised to 4 times 6x plus 4. And that's already our derivative. So that is already f prime of x. That is our final answer. So C, chain rule helps you save time in solving the derivative of complicated functions. Now let's have example 4. Solve for the derivative of f of x equals the square root of 3x squared minus 5. Notice that what we are given here is a radical function. So our first step will be, we will rewrite our radical function into power function. So we have here f of x equals the square root of 3x squared minus 5. That is just equal to f of x equals the quantity 3x squared minus 5 raised to 1/2. Okay, now that we have expressed our radical function into power function, then it's easier for us to identify the u. So our u, we let u be equal to the inner or the inside function. We have 3x squared minus 5. So 3x squared minus 5. And then we write f of x equals the quantity 3x squared minus 5 raised to 1/2. By equals u raised to 1/2. Now we can already start solving for the derivative. So we have f prime of x is equal to the derivative of y with respect to u times the derivative of u with respect to x. So we have here the derivative of y. Our y is u raised to 1/2. So we have u raised to 1/2 with respect to u times the derivative of u, which is 3x squared minus 5. So we have 3x squared minus 5 with respect to x. Now the derivative of u raised to 1/2 is 1/2 u. 1/2 minus 1 is negative 1/2 times the derivative of 3x squared minus 5 is 6x. Next step will be substitute our predefined value of u, which is 3x squared minus 5. So we have here 1/2 times 3x squared minus 5 raised to negative 1/2 times 6x. Now looking here, we can see that we can simplify, or we can divide 6x by 1/2. So f prime of x is equal to 6x divided by 1/2 is 3x times the quantity 3x squared minus 5 raised to negative 1/2. Now we know that quantity 3x squared minus 5 raised to negative 1/2 is equal to 1 over the square root of 3x squared minus 5, meaning our final answer would be f prime of x is equal to 3x over the square root of 3x squared minus 5. And that is already our final answer. Alright, so that's how basically to perform chain rule, especially when we are dealing with composite functions or functions that are a little complicated.